3.3 day one. We're about to crank out a lot of different derivatives here. Let's talk about what we learned yesterday in our Desmos activity. The first thing that we should have learned is the derivative of natural log of x is 1 over x. The derivative of a constant function is 0. The power rule, which is if you have some function x to the n, you get n times x to the n minus 1. And finally, if you have a constant in front of it, you really don't do anything with the constant. So a constant just kind of stays there. So it's a times n to the x to the n minus 1. I'm really struggling with that. So really quick, an example of this would be if you have a function f of x equals x to the 5th, the derivative equals 5x to the 4th. If my function was 10x to the 5th, my derivative is going to be 5 times 10, which is 50x to the 4th. So that a just kind of stays out in front. I'm going to give you a little bit of time to do these review practice problems, and then I will put the answers up. So here are the answers. Hopefully you got them right. If you need some help, ask in class. Okay, next, let's talk about some new rules. We have a lot of new rules today. The sum and difference rule. So if you have two different separate parts separated by a plus or minus sign, and you take the derivative, you get the derivative of u, which I'm going to call u prime, plus or minus the derivative of v, which I'll call v prime. Okay, so u plus or minus v, we take the derivative. That means we just take the derivative of each part separately. So real quick, for example, if I have, let's say, 10x squared plus 5x, and that's my f of x, and I want to take the derivative of this would be 20x plus 5. So I take the derivative of each part separately. The product rule, that's when I have the product of two different things. If u and v are differentiable functions of x and they're a product of each other, I do what's called the product rule. That's the derivative of the first times the second plus the derivative of the second times the first. So that's the product rule. Derivative of the first times the second plus the derivative of the second times the first. So in other words, derivative of u times v plus derivative of v times u. Here's a quick example. If I have a function 3x squared plus 8 times 4x minus 6, and I want to take the derivative of that, what I'm going to do is I'm going to take the derivative of the first part, which would be 6x, and then I'm going to multiply that by the second part, 4x minus 6, and then I will add that to the derivative of the second part, which is 4, times the first, so 3x squared plus 8. That's called the product rule. Finally, the quotient rule. For the first time I made this video, I kind of screwed up the quotient rule, so I'm going to make sure that I don't screw it up this time. The quotient rule, if we have two differentiable functions of x, u and v, it is the derivative of u times v minus the derivative of v times u all over v squared. I have another couple ways that you might want to remember it, depending on the way that you think. The way that I tend to think about it is the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. You can also remember it as the low function times the derivative of the high function minus the high function minus the derivative of the low function all over the low function squared. Low d high minus high d low all over low squared. So I'm going to do a couple of these real quick. The derivative in number 7, I just take the derivative of each part separately, so that's 6x plus 2. The derivative in number 8, I'm going to take the derivative of each part separately, so that is 4x cubed over 3 minus 10x. In number 9, this one looks like a product rule, so the derivative of the first is going to be 6x plus 2 times the second, which is 2x minus 6, plus the derivative of the second, which is 2, times the first, which is 3x squared plus 2x. Could I simplify this? Absolutely. It depends on the problem as to whether you would have to simplify it in, for example, on the AP test or whatever. If this is multiple choice, you would probably have to simplify it. If it's free response, you could probably leave it like this for the first part, but if you would need to use it later on, you might have to simplify it in order to get things done a little bit easier. So I will do a little bit of mathematics here. So this is going to end up being 18x squared minus 28x minus 12. You can double check me on that later on and tell me if it's wrong, and then I'll make a new video for next year. Okay, now one thing that you might notice is that if you distributed beforehand, okay, so if you distributed beforehand, like let's say you get 6x cubed minus 14x squared minus 12x, and then you just took the derivative of each part separately, you would get the final answer that way. So there are multiple ways to do these problems. You could have done it that way. You could have done it with the product rule, variety of different ways. From now on, I'm just going to use the rule that we are working on in particular. So in number 10, this is, again, we're practicing the product rule. So I'm going to take the derivative of the first, which is 2x, times the second, which is x cubed plus 3. I'm going to add that to the derivative of the second, which is 3x squared, times the first part, which is x squared plus 1. I'm not going to simplify at the moment because I have a long way to go in this video still. The derivative of this one, well, it looks like this is going to be the quotient rule. Derivative of the top times the bottom. So the derivative of the top is 2x, and I'm going to multiply that by the bottom. That's x squared plus 1. Minus the derivative of the bottom, which is 2x, times the numerator, x squared minus 1. All over the bottom squared, or all over the denominator squared. So this is the derivative of that function. There is a lot of simplifying that can be done to the numerator, but I'm going to leave that to your algebra abilities. Number 12, the derivative of the top is 3x squared. I'm going to multiply that by the denominator. Subtract the derivative of the denominator times the numerator. And then all over the denominator squared. Notice that I have to put the 2x in parentheses to square it, and it'll become 4x squared if I square the whole thing. Power rule for negative integers. So using the power rule for negative integers to find the derivative of what we just did above, I guess I should probably tell you what the power rule for negative integers is first. So the power rule for negative integers is the same thing. So if we take a look at this function, if I actually divided this function out, I'm going to rewrite this as what happens if I take that function and I turn it into two separate terms. So that would be x squared over 2 plus 3 over 2x. So the derivative of the first one is easy. That's 2x over 2, which we're going to simplify to x later. But this guy, remember that x in the denominator is the same thing as saying x to the negative 1. So what I'm going to do here is I'm going to take this negative 1, I'm going to move it down, and it's going to turn into something that we multiply. Okay, so in our example here, this n would be a -1. And then notice that n minus 1 becomes -2 in this case. -1 minus 1 becomes -2. So this is going to be 3/2 times -1 x to the -2. Okay, so that -1 moves down, and then it's -1 minus 1, which becomes -2. So let's simplify this. 2x over 2 just becomes x. And then if I simplify this, it becomes minus 3 over 2x squared. As remember, x to the -2 I can rewrite with an x in the denominator. And then the rest is practice for you. I'll put answers up very shortly. Press pause if you need to, and then I will put the answers up. Check your answers now. 1, 2, 3, and 4 are up. One thing to notice on number 4 is I did not write the derivative of the numerator or the denominator in these spots, but they're both 1. So I could have written the denominator or the derivatives in, but I did not write them in that particular case. Also, they won't care if you write x to the -3 or x to the third in the denominator. Neither one of those is better or worse than the other in terms of acceptability. However, it is possible that one of them may be easier to use than the other in particular instances. Here's 5, 6, 7, and 8. I didn't simplify a lot of these, like number 8. I didn't simplify. You can if you want. Number 6, I wanted to show you that sometimes one way is way easier than the other. So if you recognize that you can divide out that x squared in f of x, that makes taking the derivative way easier because the power rule is a whole lot easier than the quotient rule. And so that's very important to understand. Sometimes it is way, way, way easier to do a little bit of algebraic manipulation before you take a derivative. So that is our video lesson on the derivative rules.